The Reverend Thomas Bayes was a Presbyterian minister near London in the middle of the 18th century. In addition to serving his congregation, he did some scholarly work on theological matters and also on mathematical topics. He is most well known today for a theorem called Bayes' theorem, but he didn't name it himself. He didn't even publish it. A friend of his named Richard Price published the theorem when he found it among Bayes' papers after he died. Bayes' name is also associated with a way of thinking about probability that may be a bit different than what you're used to. Most people are used to thinking about probability in terms of long-run frequencies. You expect that if you flip a coin 100 times, it will come up heads about 50 times. Or if you draw 6 of 40 numbered balls out of a tumbler, like in many lotteries, each ball will come out of the tumbler about an equal number of times in the long run. Another way to think about probability is as a degree of belief. That may sound somewhat subjective. What one person believes could be different than what another person believes. But a standard set of procedures based on Bayes' work allows us to make inferences about how new evidence should be merged with existing beliefs to produce a new belief. Bayes used a thought experiment to make this a bit more intuitive. Let's take a look at this now. Bayes is going to haphazardly toss a landmark over his shoulder onto the table behind him, like this. But he doesn't get to look at where it landed. The landmark could come to rest anywhere. Think of the table as a map, with north, south, east, and west sides. How likely do you think it is that the landmark is in any one location? Part of Bayes' idea was that we'll start by assuming there's an even chance of the landmark resting on any one location. Now, Bayes will toss a marker onto the table, and his assistant is going to tell us where that marker is relative to the landmark. The marker will be north or south and east or west of the landmark. The assistant tells us it is north and east of the landmark. Okay, so now let's go back to your guess about where the landmark is. Now that you know the marker landed north and east, what's your best guess about where the landmark is? So we started out thinking all of the locations were equally likely. So a good way to represent our initial guess is in the center of the table, kind of an average of all the locations. Now, Bayes is going to take this new piece of information and combine it with those prior beliefs to form a new belief. How likely is it that the landmark is here, southwest corner? Or how about here, northeast corner? It's not very likely that it's in the far northeast corner, right? Because the marker is northeast of the landmark has to be at least a little ways from the corner to allow room for the marker to land. The marker could still be just about anywhere, but now it seems a bit less likely that it's close to the northeast corner. If we think about the whole map, this new piece of evidence kind of tilts all the probabilities a little bit toward the southwest. So Bayes is going to mark a new guess a little bit southwest of the center of the table. Now watch Bayes toss the marker again. And now the assistant tells us the marker is south and east of the landmark. Okay, so after last time, we might have been starting to think the landmark was toward the south because the first marker landed north of it. But now we have another marker south of it. So that might make us a little less certain about where we are in the north-south axis. But both the first and second markers were east of the landmark, which might suggest that the landmark is somewhere in the western part of the table. We can't be sure, but that's what the evidence so far would suggest. So now Bayes moves his guess back up to about halfway between north and south, but a little more west. Okay, another toss, and this time the marker is northeast of the landmark. On to the next toss. The marker is northwest of the landmark. And another toss after that, the marker is northeast of the landmark. And so it goes over and over. And the longer we collect new evidence and use it to update our belief about where on the map the landmark is positioned, the closer we will eventually be to the actual location. This thought experiment.